A very good afternoon. My name is Tom Brijs. I'm the project coordinator of the Horizon 2020 project called iDreams, with the title Safety Tolerance Zone Calculation and Interventions for Driver-Vehicle Environment Interactions under Challenging Conditions. The project runs from May 2019 until April 2022, so we are now about half in the project. The project is coordinated by the Transportation Research Institute of Hasselt University in Belgium in collaboration with another set of research institutions across Europe, 4 different companies and ICT groups, and 2 partners with links to the transport safety stakeholders and industry. Let me first give you some background to the project. As we all know, human factors are the largest cause of collisions across all transport modes. Now, at the same time, technical developments and automation will heavily change how humans interact with road or real vehicles in the future. For example, new evolving technologies will change how humans perceive their immediate environment and traffic and how they will interact with machines. As a result of that, there is a need for sufficient and relevant data on human factors to better understand the impact of the interaction between human beings and vehicles while they are driving. At the same time, we are in need of better methodologies to assess human factors and to better understand and address the bottlenecks in organizational acceptance of technologies and social change and the governance of complex integrated systems. The project addresses this challenge as follows, as being displayed here on this overall overview graph that consists basically of 2 components. First of all, the monitoring component here at the left-hand side of the figure and the intervention component at the right-hand side of the figure. And the connection between these 2 is made by the so-called safety tolerance zone, which is a very central concept in this project. Let me explain a little bit more. So the monitoring part is a set of tools and technologies to monitor, measure in real time information from the road context, the operator status, and the vehicle status. So, for example, we have tools on board to measure the current driving context, such as the time, the location of driving, the current weather situation, for example, other traffic in front of the vehicle. We are measuring operator information, for example, through a steering wheel cover that measures the heart rate of the driver to identify a potential sleepiness, or we are measuring through the smartphone whether the driver is holding the smartphone while driving, and a series of information from the vehicle, such as the current speed, RPM value, fuel consumption, etc. With all that information, we estimate the task complexity and the coping capacity, which will together determine the status of the safety tolerance zone. And the safety tolerance zone typically has 3 stages, as we have defined them, called a normal driving stage, a danger stage, and an avoidable accident stage. So at every moment during the trip, all the information is being fused together to evaluate where the driver is currently in each of those 3 stages. And depending on that, interventions are triggered or not. For example, in the normal driving stage, no intervention is triggered, while in the danger phase, a warning signal or alert will be given to the driver in the vehicle through a real-time intervention device. And in the avoidable accident stage, where the driver really needs to intervene in order to avoid an accident, a more intrusive signal or instruction is given to the driver. Now, we strongly believe that it's not only in-vehicle interventions that are important, but in order to achieve better driver performance and higher road safety, we need to coach also the driver to improve his behavior, and this is done through the component of post-trip interventions, which basically is divided into 2 parts. That is a driver app on which the driver will receive scores and also tips and feedback on how to improve his behavior based on his own performance during past trips. And a gamified web platform that can be used by a company coach or driver planner to monitor a series of drivers that are taking part in the iDreams project. Let me illustrate this concept by a short explainer project video, which will demonstrate the different components more clearly.
This is Emma. She returns home after a long day at work. Traffic is busy, but she's assisted by iDreams. This system knows Emma has had a very busy day and constantly monitors her heartbeat, driving behavior, and the road. When safety is no longer guaranteed, iDreams warns Emma to keep her in the safety tolerance zone. It has 3 phases. The safe driving phase, where everything is okay. The danger phase, where there is an increased risk of collision. And the avoidable accident phase, that insists on intervention to avoid dramatic consequences. After a long day at work, iDreams is more watchful to ensure Emma stays alert for potential dangers on the road. After her trip, she receives feedback to give her insight in her own driving behavior. Welcome home.
Okay, so let me demonstrate a little bit further the purpose of the in-vehicle interventions and the post-trip interventions. So what you have seen in the video is that we trigger interventions in the vehicle with the ultimate goal to keep the driver in the safe zone of operation as long as possible. We will trigger alerts, however, when a risk event is being detected and it is clear that the driver is not completely under control to deal with it. And we do that by monitoring the complex interaction between driver, vehicle, and environment. Specific alerts are being developed in the project for sleepiness and fatigue warning, for illegal overtaking, for speeding, and for tailgating. Where, and that has to be emphasized, the timing of the triggering of those alerts is not only based on the road conditions or the vehicle conditions, but also on the operator state in real time. For example, if the driver is distracted or if the driver is sleepy. In the vehicle, we are measuring at the same time or logging all that information. We are measuring the reactions of the driver to those warnings and storing that information in the cloud for processing and feeding that information back to the driver, and to better understand, of course, the different conditions that contribute to risky events. For the post-trip interventions, we have a double strategy. The first part is the driver app, where information is being fed back to the driver about his past performance. So he will receive scores on different components of his driving behavior. But at the same time, we challenge the driver to improve his behavior by setting goals. When achieving those goals, the driver will be able to obtain badges or will obtain credits, where those credits can be exchanged for products in a shop. The driver can compare his own performance against the performance of other drivers in the leaderboard, etc. So basically, a full gamified platform helping the driver to improve his behavior. At the right-hand side, we see the gamified web platform. This is actually the monitoring platform for the driver coach or the company planner in order to follow up on a group of drivers. And that dashboard will help the driver coach to manage the gamification components, but at the same time, for example, to look into specific trips and events that took place during those trips. And for example, to play a video for a specific event that is being recorded by the dash cam in the vehicle to see exactly what happened during a particular risky event. The technology platform consists of a central data logging unit, which we call the gateway. On that gateway are several sensors being connected, a dash cam, a Mobileye system, a GPS, an OBD logger. We measure heart rate through the steering wheel to identify fatigue and sleepiness, or a wristband collecting information about the sleepiness of the driver. That information is processed in real time by the gateway, and if needed, alerts are sent to an in-vehicle real-time intervention display. And after the trip, all the information is sent to a cloud system that processes the data from each trip, feeds back the scores and gamification components both to the driver app and to the company's gamified web platform. The current status is that we have a prototype of this iDreams platform ready and deployed in a couple of pilot vehicles. We are currently testing the technology. You see here the real-time intervention display, and we're comparing it to existing displays on the market. We have the dash cam in the vehicle, the Mobileye, etc. The next step is that we are testing all these real-time interventions and the safety tolerance zone in simulated conditions, first of all, in driving simulators, but then the next step also in the field in 5 different countries, as you can see here: UK, Belgium, Germany, Portugal, and Greece, and across different transport modes, including car, truck, bus, and tram. The final output of the project will be a series of methodologies and tools for monitoring the operator capacity and task complexity, and to determine this stage of the safety tolerance zone in which the driver is situated in real time. A set of intervention tools and support tools, including in-vehicle assistance, as well as post-trip feedback and notification tools. A human factors database where information will be stored and anonymized for future research purposes. A set of exploitation plans for the commercial use of the iDreams system after the project. And finally, a set of policy recommendations for authorities on how to implement the iDreams platform. By this, I wish to end my presentation. I thank you for your attention. Please subscribe to our social media channels, and do not hesitate to ask questions. We are available for your questions. Thank you very much.